Alright, so this is preparing you for the pre-algebra final. So let's see how we can go about doing this. The first set of questions 1 through 8. So I'll pick similar questions for each problem, so you have an idea how to do it without giving you the answer. So let's go about it. The first question is negative 19 plus 12. Well, you know what? Let's just change it up. So I'll put negative 20 plus 12. Now we went over this many times, adding positives and negatives. But the thing is this. All you have to do is when you have one negative and one positive, when you have one negative and one positive, you're going to subtract the numbers from each other and take the sign of the larger. It doesn't matter what the order is. So 20 from 12 is 8. Alright, is 8. What number is bigger? The 20. And because it is a negative, the answer is going to be negative 20. Alright, easy. Next problem is number 2 is 20 plus 4. I don't need to go over that. You should know how to do that. Number 3 is negative 20 minus 4. I'll make it into a minus minus 10 instead. Alright, so you see with this problem there's one negative and one positive. But in this problem there's two negatives. So when signs are the same, right, all you do is add them together and take the sign of both numbers. Well, the sign of both numbers is negative, but just all we have to do is add them. So 20 plus 10 is 30, and because they're both negatives, the answer is going to be negative. Easy enough. Right? Now, next problem is number 4. Number 4 is we have negative 19 minus 12. Well, let's change this 19 to 20 minus, we'll say minus 10 once again. Alright, this is a little confusing, but it's not. What we're looking at here is we see two negatives next to each other. So those two negatives become a positive. So let's rewrite the problem. So this becomes negative 20 plus 10. Now, same philosophy, you have one negative and one positive. Because you have one negative and one positive, you subtract the numbers from each other. So 20 minus 10 or 10 minus 20 is 10. And then we take the sign of the larger number. The larger number is negative 20. So the answer is going to be negative 10. Alright, easy. Number 5, you should be able to figure that out. Number 6, same philosophy. Negative 9 minus 3, you subtract them from each other, take the sign of the larger. Number 7 is 1 plus 3, you should figure that out. And 1 minus 3, once again, you subtract them from each other and take the sign of the larger. Number 9. Number 9 is negative 48 divided by 6. I'll change the numbers to... I'll change the numbers to negative... I'll change it to negative 24. There we go. Negative 24 divide by 6. Well, 24 divided by 6 is what? It's 4. And since there's one negative, the answer is going to be negative. But if this was negative 24 divided by negative 6, the answer would be positive. Does that make sense? So negative times positive equals negative. Negative times negative equals positive. Alright? Only when it comes to multiplication. Alright, so that should help you with numbers 10, 11, and 12. 13 and 14. 15 you should be able to do. 16 may trick you a little bit, so let me try to help you out there. So number 16 is not tricky if you just use a little bit of common sense. So we have 1/2. So let me change the 1/2 to maybe 1/4 times, let's say 24. Alright, I have the number written like this. Well, another way to write it is 1/4 times 24 over 1. Does that make sense? Hope it does. Now all you have to do is see if you can cross cancel. Well, how many times can 4 go into 24? 4 can go into 24 6 times. So change that to 1 and this becomes a 6. The answer is 6 over 1, or simply 6. Alright, same philosophy applies. Next is x over x to the 8th power times x to the 2nd power, so I'll change that to 3rd power. Now, because the bases are the same, alright, since this is an x and this is an x, all we have to do is just add the exponents, 8 plus 3. So 8 plus 3, right, will give us x to the 11th power. So that's all we're doing there, alright? Now, let's say this was a division sign, right? X divided by. Same philosophy. With multiplication we add, so with division we subtract. So 8 minus 3 is 5, which is x to the 5th power. Alright, makes sense. I hope it does. Okay, next problem is is 9 to the 9th power over 9 to the 5th power. Well, I'll change it to n to the 12th power over n to the 4th power. Alright, that's the same thing as saying n to the 12th divide by 9 to the 4th. And all we did was subtract. So 12 minus 4 is 8. So it's n to the 8th power. Okay? Hope that helps you out. Now, the next one's a little bit hard. We have 4 to the 2nd plus 2 to the 4th. So I'll change that 2 to the 4th to 6 to the 4th. Now, the problem is nothing's the same. The bases are not the same, and the exponents are not the same. So this creates a little bit of a problem. So the only way to go about solving this is to actually find out what the numbers are worth. Actually, that's the only way we could do this. So 4 squared is 16, and 64 to the 4th power. 6 to the 4th power is, I don't know. 6 times 6 is 36. So we're doing 36 times 36. Alright, so 6 times 6 is 36. 6 times 3 is 18. Alright, so we have 18 plus 18, which is, this becomes 2, 10. We have 16, 10, 36. 39. 3 times 3 is 9. 9 plus 3 is what? 12. Okay, so the answer is 1296, alright? So 16 plus 1296, and that will give you your answer. So the same thing you're going to have to work out for number 20. If you noticed, I did the math, the multiplication style that I had taught you earlier, and the addition style which I taught you. 18 plus 18, I did 36. Simply 10 plus 10 is 20, and 8 plus 8 is 16. So I'm adding that 1 to the 20, which becomes 36, alright? And I use the cross multiplying to help us get the answer rather quickly in my head. Alright, one particular student did not like me teaching you how to do that. Anyway, let's continue on. Next is scientific notation. So the example that I gave you was, let's do a 0.0. How many zeros are there in question number 21? 1 after the decimal. 1, 2, 3, 4, right? So 1, 2, 3, 4, and I'll write another number, 56. All we're doing is moving the decimal point to before the last number. So how many places did we move it? Well, we're moving it 1, 2, 3, 4, 5. So we moved it 5 places. So the answer is going to be 5.6 times 10 to the negative 5th power, because we went this way. If we went the other way, it would be positive. Alright? So that makes sense with number 22. The answer, just to give you a hint, it's going to be 7.49 times 10 to what positive number? You should be able to figure that out by yourself. Number 23, I'm asking you to work it out. Alright, so we have, well, here I'll just do an example, a simple example. We have 3.40, I'll just do 3.4 times 10 to the, let's say 10 to the 5th power. Alright, all we're doing is moving the decimal place 5 places this way. Alright, so we go 1, 2, 3, 4, 5. So 0, 0, 0, 0, decimal 0. So the answer is 3, 4, 0, 0, 0, 0.0, which is 34, which is 340, comma 0, 0, 0. Alright, there you go. And then 51 would be the opposite way. Alright, not hard. Now, distributed property. We have 8, 7 plus 6. So I'll put 2. All we're doing is distributed property. We're doing 8 times 7 and 8 times 2. That's all. 8 times 7 is 56. And 8 plus 2 is 8 times 2 is 16. And then we add those two together. Alright? And just to linear 56 plus 16. Once again, this is 60 and that's 12. So the answer is 72. Alright? 53. Let's do 53. There's an unknown, so that may throw some of you off. We have 3, and I'll change the numbers to 2x minus 5. Alright? Same thing. 3 times 2x becomes 6x, and then 3 times minus 5 becomes minus 15. We can't add these two together because they're different terms. Alright? Let's see here. Next we have negative 9, so I'll change that to negative 3 times x plus 2. Alright, negative 3 times x becomes negative 3x, and negative 3 times positive 2 becomes negative 6. Alright, that's how you would go about that. Alright, another example there, similar to number 55. Let's say I have x times x plus 3. Alright, x times x becomes x squared, and x times 3 becomes 3x. Alrighty, hope you can get that. And then number 56 is, looks a little bit harder, but we can figure that out. Let's say we have 6 times x plus 2 plus 3 times x, we'll put plus 5 for example. Same philosophy, we gotta move 6 times x and 6 times 2. 6 times x is 6x, 6 times 2 is plus 12. Alright, next. 3 times x is 3x. 3 times 5 is 15. Now we have to look for like terms. These x's are like terms, and these regular numbers are like terms. All we have to do is add them, right? Well, 12 plus 15 is what? 27. Right? And 6x plus 3x is 9x. So we have the answer is 9x plus 27. Alright? And similar answer for 56. 57 is same philosophy. Well, there is a negative, so let me help you out there. Alright, I'm going to help you out there. So we have 4 times z plus b, and changing the terms, minus 5 times z minus b. Alright, so here we go. 4 times z is 4z, 4 times b is 4b. Alright, negative 5 times z is negative 5z. Negative 5 times negative b, because this is a negative and this is a negative, it becomes a positive 5b. Now all we have to do is add like terms. Let's do the z's. 4z minus 5z is just 1z, or z you could say. Alright, z. And we have 4b plus 5b is simply 9b. Alright, so 58 you should be able to do, but well, I guess let me try to help you there. Shouldn't, but I will. So we have a, I'll put, I should change everything, so I'll make this a d plus b. Yeah, that's what I'll do. I'll change it up on you. Plus b, d minus a, plus d, and I'll have a minus b. Alright, so I changed it up on you. A times d becomes ad, a times b becomes ab. Alright, b times d becomes bd, b times a becomes ba. You know, I'll change it to ab because I see some similar terms. Plus d times a becomes ad, technically da, but you could change it around. And d times b becomes negative bd. Alright, let's look for like terms. So we have ad here, or da, oh, here's another ad. ad plus ad becomes 2ad. Alright, so that takes care of the ads. Next, let's do ab. There's an ab or ba. There's an AB or BA, just those two, AB plus minus AB. Oh, those go out with them. These drop out. Next one. Let's choose a different color. We got a BD or DB. We have a negative BD, BD, and these also cross out. So the answer is just 2AD. I'm not sure what the answer will be after you work out on your own paper, but let's see since the terms are different. Alright, next. We have to evaluate. Well, I'm going to give you the answer to 59. Alright? One time. So we have 2a. No, I don't have to give the answer. I'll change the first number. 4a minus b. Alright, so we have a equals negative 7. Right? And b equals 12. All we have to do is plug it in. So we have 4 times negative 7. Alright, I'm putting this in parentheses so we don't get confused. Minus b, which is 12. 4 times negative 27 is negative 28. Minus 12. Oh, well, we know since they're both minuses, the answer is going to be a bigger negative. We just have to add them. So we have to add 28 plus 12. Well, 20 plus 10 is 30, and this is a 10, so the answer is negative 40. Alright, so same philosophy applies to the others. 60 you should be able to do. 61 you should be able to do by yourselves. That's division. And 62 you should be able to do by yourselves. Alright. I'm contemplating whether I should help you or not, but I think you should be able to do it on your own. Next, write each word phrase as an algebraic expression. Well, the product of negative 9 and n. The product of negative 9 and n. Well, if I were to say, and focus, if I were to say what is the product of negative 2 and x, all we're doing is just multiplying negative 2 times x, or negative 2x. What is the product of that? So it's the same thing that they're asking. What is the product of negative 9 and n? What is the product of 2 apples and I don't know, and 3? So it'll be just 2 and 3. Alright, something like that. Next is 26. 23 increased by twice m. Alright, well, what about if I say 10 increased, right? Increased by twice, twice z or something like that. So I'm saying 10 increased means addition by 2 times z, or 2z. Alright, that's how you would go about that. Next is, it says 64 less than the product of 5 and p. So if I say 65, or let's say 50, less than, which is minus, the product, what does product mean? That means it's a multiplication, the product of 5 and p. 50 less than the product of 5 and p, well, it'll just be minus 5p. Alright, so hopefully you should be able to figure that out. The difference of 12 and a, well, that's just subtraction. Alrighty, 67, 68, 69, 70. I will do some examples with you. I have x minus 2 equals 12. Alright, we have to get x by itself. The easiest way to get x by itself is to add 2 to both sides. X equals 10. Alright, after we solve that. Next is, I'll put 5m plus 10 equals 20. Alright, same philosophy. We have to get rid of, we have to get 5m by itself. The variable by itself, what's the opposite of plus 10 is minus 10. We need to get rid of that. This crosses out. We're left with 5m equals 10. Now we have to divide 5 by both sides. And after we cross everything out, we're left with m equals 2 over 1, which is the same thing as 2. Alright, next is, I'll put 6x over 3 equals, let's say 27. Alright, or 27 over 1. So let's see here, what can we do to make this easy? There's a lot of things I see I can do. I can make this into a proportion, actually. But let's see, I did teach you all that. But to make it simpler, I'll just get rid of the 3. Alright. So, let's do, I'll multiply the inverse of 3 over 1 on both sides. Alright, or you can do proportions too, whatever way works for you. This crosses out, and then we have 27 times 3. I'm not sure what that is on top of my head, so I'll work it out. 27 times 3 is 81. So we have 6x equals 81. Now we have to divide both sides by 6. So after you divide 81, or see how many times 6 goes into 81, you have your answer. Same philosophy applies for the problem. More or less same style of working the problem. Next is 7x minus 10 for number 70 plus 5x equals, let's say negative 51. Alright, we have to combine like terms, which makes it easy. 7x plus 5x is, what is that, 12x. and then minus 10 equals negative 51. Well, we need to get 51 by its, we need to get 12x by itself, so we'll add 10 to both sides. So then we're left with 12x equals negative 51 plus 10, which is negative 41. And then we have to divide 12 by both sides. And you get the answer. Same philosophy applies in numbers 62. I mean numbers 70. Alright. Next is 71. Is reducing. I don't know if I should even teach you that. That's silly. Alright, well, we have 10 over 25. The greatest common factor between these two, I think, is 5, looking at this. So we're dividing each number by we're dividing each number by the same number, 5. 5 goes into 10, 5 goes into 25, 5. So that's 2 over 5. Alright, now one that may give you a little bit of trouble is maybe 73, which is, let's say we have negative 10 and 2 to the 5th power. Alright, so we got to change this into an improper fraction. So 5 times 10 is 50. 50 plus 2 is 52, right? Negative 52 over 5. Let's see if you can reduce it. And here we can't reduce it, but maybe in that problem you can. And same philosophy applies for 74. And with 75, let me just show you an example of 75. Something similar. Let's say we have 20 over 4. We can divide each side. We can divide each number by 4 actually. 4 goes into 4 one time. 4 goes into 25 times. So it's 5 over 1, or just 5. Okay, that takes care of that. So convert to decimal. 76 to 80. We'll do number 76 with you. So we have 2 over 5. To make into decimal, we have to do the division. 5 into 2. Remember, this stays there and this drops into the box. If that makes it helpful. Alright, 5 can't go into 2, so we have to add a decimal and a 0, and a 0 and a decimal here. 5 goes into 20 how many times? 4. 5 times 4 is 20. So the answer is 0.4. Now if I were to ask you to write this as a percent, 0.4 or 0.40, right? 0.40 becomes 40%, because all you're doing is moving the decimal 2 places to get you 40%. Alright. Let's do another one. I'll do 78 with you. Help you out. We have 15 over 8, or 8 into 15. Well, 8 can't go into 15, so we have to add our 0. Our 0 here. Now, how many times can 8 go into 150? Well, that's a little bit tough. Well, what's 8 times 12? Or 12 times 8? Well, 12 times 8 is... 2 times 8 is 16. 96. 96 seems right. Well, let's try that. Oh, actually, you know what? I made a mistake, students. Before we begin, can 8 go into 15? Yes. 8 can go into 15 one time. 15 minus 8 is what? 15 minus 8 is 3, 11, 7. Sorry, I wasn't thinking. Well, 8 can go into 7, so 7 is the remainder, but we don't want remainders. So we'll add a point and put a 0 and a point here. Alright, bring down this 0. There we go. Can 8 go into 70? No. Well, it can by 8 times 8 is 64, so we'll put an 8 here. 8 times 8 is 64, right? Now 70 minus 64 is 60. Alright. Can 8 go into 60? Well, 8 times 5 is 40. 8 times 8 is 6. We We could do 7. 8 times 7 is 56. Alright? Well, that gives us 40. Right? We'll add another 0. That gives us 40. Can 8 go into 40? 8 times 5 is 40. Yes. So the answer is 1.875. Isn't that interesting? And if I were to ask you to write this as a percent, we would move the decimal 2 places this way, and the answer would be 187.5%. If I were to ask you. Alright? That was a good example, actually. Alright, next is proportions. Alright, so let's say I have x over b equals x over b. Why did I do that? Well, alright. I'll actually will have to go over this problem because I made a mistake. Alright, how do we go about this? The way we do this is we need to cross multiply. Alright. That's all. So that becomes x times 15 becomes 15x equals 14 times b, which is 14b. And that's simply the answer for this problem because I made a mistake. I wouldn't want you to do anything besides that. I mean, you could get x by itself, which you would have to divide both sides by 15. And the answer will be x equals 14b over 15. But we really haven't done much of that, so I won't let that go against you. Let's pick a decent problem. Let's pick number 82. So 82 is, we have 8. So we have, I'll change that to 10 over b equals 10. We'll make it 20 over 40. Alright, the way it works is same way we have to cross multiply. Alright, and then we'll get our answer. 10 times 40 is 400. And b times 20 is b20. Now we have to divide both sides by 20. Divide this by 20. This crosses out. And divide this by 20. The zeros cross out. So 2 goes into 40 20 times. So the answer is b equals 20. Alright? So that's the same way applies to 83, but you got negatives, so don't let that confuse you. And 84. Next is 85. Let's see what we're doing for 85. It says perform the functions. So there's several things that we're doing, and well, each problem is different. Well, let's do. Well, let's start at it then. So I have 7 over 9 plus 4 over 9, which I'll just, oh, well that's easy. I'll not put 6 over 9. I'll make it 2 over 9. No, I should make it bigger. Okay. Alright, first thing is first is we're adding fractions. Before we even add fractions, we have to see if the denominators are the same. Well, the denominators are the same, so that makes it a lot easier. So all we have to do is add. 7 plus 3 is 10, but we got a problem because it's an improper fraction, so we have to make this fraction into a proper fraction. And the one way to do that is we have to divide 9 goes into 10. 9 goes into 10 one time. 1 times 9 is 9, 10 minus 9 is 10. So I would put this is 1. I'll write 1 as 1 over 9. Okay, does that make sense? Because this fraction becomes the numerator. Alright, and this number becomes the denominator. Alright, so the answer is 1 and 1/9. For number 86, we have 8 times 1 over 5. I'll write that into 4. Minus 2 over, I have 3 over 4. So I'll make that into, 1 over 2. We can't do anything because we have a problem that denominators are not the same. So we have to change them to improper fractions. 8, so let's do this. 8 times 4 is 32 plus 1 is 33 over 4. Alright. Minus 2 times 2 is 4 plus 5 is 5 over 2. Well, I need to 2 goes into 4, so I can change. They both need common denominators, so I'll change this into a 4. So 2 goes into 4 2 times, so multiply each number by 2 is what we're doing. So 2 times 5 is 10. Alright, you see, I hope you see what I did. So then I can delete that because that's our new fraction. So 33 minus 10 is 23 over 4. And that's our answer. Alright, you could change it into an improper fraction by dividing 4 into 23. 4 goes into 5 times, right? Which is 3. So 3 becomes the numerator and 4 becomes the denominator. So 5 and 3/4. Alright, so that's the proper answer, I should say. Next is subtraction. Let's go over that. So we have negative 6.12, I'll make it, minus 0.215. Alright, when subtracting, we gotta line up the decimals. So we have negative 6.12 minus 0.215. I can put a 0 here. Well, since they're both negatives, we're just adding them then. So it's going to be 533.6 negative. Okay, that was easy. 88, you need to have a common denominator. 89, you know what to do. 90, let's go over 90. Let's say with 90 you have 7 over 3 times 4 over 6. Well, you want to see if you can reduce anything, which we can't. So we just have to multiply. 7 times 4 is... Well, actually we can reduce in this problem, but not in the problem that I gave you. Because, let's see. 4. We can choose 2. We can divide each number by 2. Okay, well then that helps a little bit. 7 times 2 is 14. 3 times 3 is 9. So the answer is 14 over 9. Alright, and then we could also change into a proper fraction, whatever you wish. Alright, delete that. 91, same philosophy. Okay, 92 is a little bit difficult, and 93. So let's go over, let's go over 92. So with 92, we have 3 over 7 divided by this negative number, which shouldn't scare you. Let's say I have negative 9 over 4, so I'll change it 8 to 6. Well, when we're doing division, we have to flip one side. We have to change this to a multiplication problem and change this to 6 over 8 negative. Right? Since we know that there's one negative and one positive, we know the answer is going to be negative. So I'll put the negative there already. Alright, let's see if we can cross cancel. Nothing can cross cancel. Well, this can again. We can divide each number by 2. So this becomes 3 and this becomes a 4. Alright, now multiply 3 times 3 is 9. And 7 times 4 is what? 28. Right, so that's our answer. Negative 9 over 28. Same thing with 93. You're going to have to change that into improper fraction and then divide. Well, let's do it together. Doesn't hurt to help you out. Let's change that 5 to, we'll change this to 4 over 5 divided by 6 over 15. We'll leave that. 5 times 5 is 25. 25 plus 4 is 29. So you have 29 over 5 times 15 over 6. Oh, we can do some cross canceling. This becomes 1. This becomes a 3. I divided both sides by 5. 3. 6 goes into, 3 goes into 6 2 times, and 29 divided by 3. So I'm dividing by 3. Let's see, can I go into there? I think it, oh no it can't. Oops. So I was jumping ahead of myself. Oh, but 3 can go into 6 though, yes. 3 becomes 1. 3 goes into 6 2 times. Oh, okay. Well, that's easy. So then after we multiply them, we just have 29 over 2. Look at that. Alright. Okay. Next. Ooh. Next is we had this very difficult problem. Oh, well, it's not that difficult. We can do this. This is with the scientific notation. So, in class, we had a little trouble with this. But the rest, well, let's figure it out. Alright. We have 3 point, let's change that to 62 times 10 to the 8th power plus 6.776, let's say, times 10 to the 8th power. We're in luck because these are the same. And when they are the same, we don't have to worry about anything. All we have to do is add these, since this is an adding sign. Alright. So it was 3.62 plus 6.76. We make sure we have these line up, the decimal places line up. Alright. 3 plus 6 is 9. 6 plus 7 is 13. Alright, 6 plus 7, well, 60 plus 70 is, 130. 13. And 2 plus 6 is 8. 60 plus 70 is 130. Right. Yeah, 60 plus 70 is 130. Yeah. 2 plus 6 is 8. Right? Yeah. 60 plus 70 is 130. 130, 132, 132, 138. Okay, yes, very good. 138. 138, 138. Okay. Sorry about that. So I did my math wrong. 300 plus 600 is 900, right? 900. 960 plus 970 become 10. Okay. My mistake. I don't know what I was thinking. 1038. Now decimal place. Decimal goes here. Okay, everyone with me? Now, since, as I said, these are the same, it would just be 10.38 times 10 to the 8th power. Alright, fair enough. Next.